Okay, in this problem, a machine of a mass 25 kilogram is placed on a elastic foundation. A sinusoidal force of magnitude 25 Newton is applied to the machine. The frequency sweeps reveals that the maximum steady state amplitude of the vibration is 1.3 millimeter occurs when the period of response is 0.22 second. Okay, they determine the equivalent stiffness and the damping ratio of the foundation. This problem is belongs to the response of a dam system to a excitation force. Okay, let me draw the first. Let me draw the diagram including all the details. Okay, then this is the machine that is mounted on the 25 kilogram 25 kilogram the mass that is mounted on the foundation. That foundation placed on an elastic foundation. Then the equivalent system we can draw for this equivalent system representing this elastic foundation stiffness by a spring K. Then its damping property we are going to represent by this kind of C, damping coefficient. Okay, so this is the equivalent system for this foundation. Okay, then forcing function frequency, the sinusoidal force of magnitude the 25 sine omega t forcing function excitation force is applied on this in 25 kilogram mass. Consider the motion of m mass by applying the F is equal ma. We are obtaining this equation mx double dot plus cx dot plus kx is equal f sine omega t. Okay, f sine omega t. Okay, then this is the second order non-homogeneous differential equation with the constant coefficient time. The solution of this differential equation xt is a addition of a complementary function solution plus a particular integral solution. That means a particular integral solution because of this non-homogeneous part. Complementary function solution we can obtain by equating this left hand side to 0. So what is the, by equating this left hand side to 0 we are getting ae lambda 1t plus be lambda 2t plus xp x cos omega t minus 5. Okay, this is the particular integral part, this is the complementary function solution. Okay, when discussing the theory we found that this complementary function solution part is damped out in a few moments after initiating the vibration. So only remaining one is the particular integral term, this one. So that means in steady state condition we are interested about the steady state vibration of the system. So x cos omega t minus 5, this is the equation representing the vibration of this system. So then by substituting this solution in this differential equation we are obtaining this x value. What is the x value? X is equal delta st called the static deflection divided by 1 minus omega divided by omega n into square plus 2 theta omega divided by omega n into square root of total. Then the 5 also we can obtain, that means the phase shift with the excitation function phase shift. Then the 5 is equal tan inverse 2 theta omega divided by omega n divided by 1 minus omega divided by omega n into square. Okay, then we obtain this amplitude ratio by dividing this x by the delta st. By dividing x by delta st we are getting the amplitude maximum amplitude ratio x divided by delta st, we are getting maximum ratio 1 divided by 1 minus omega divided by omega n into square plus 2 theta omega divided by omega n into square root of total. Here what is delta st? You can remember f divided by k, no? F divided by k called delta st. So then you can remember how this, let me take this one as the amplitude ratio m. This how this m is vary with the frequency ratio. Actually this is m is a function of a frequency ratio. M is a function of frequency ratio. This is called amplitude ratio. Amplitude ratio is a function of frequency ratio. When discussing theory classes, we obtain how it is vary with the frequency ratio, how it is vary. Omega divided by omega n, the frequency ratio. Then omega is equal omega n situation. Omega is equal omega is equal omega n situation. This is called m. This is m. Then how it is vary? How it is vary? This is 1. That means it having this kind of variation. For theta is equal 0 situation, this is how it is vary. Then okay, this is how it is vary. So then for any theta is non equal to 0 situation, it having this kind of variation. Okay, theta is not equal to 0 situation. Here the theta is equal to 0 situation. This is the maximum value having the maximum amplitude ratio. Maximum amplitude ratio value. Okay, this theory we discuss in theory classes. In this problem, the says when switch the frequency, when switch reveals that the maximum amplitude is steady state amplitude of 1.3 millimeter. That means x maximum is equal 1.3 millimeters. Because when the period of response is equal to period of response, that means the t periodic time of excitation function, that is equal to 0.22 second. So this data is given. So then I am going to use this data to find the answer. Okay. Okay, x maximum, that is equal to 1.3 into 10 to the power of 3 in meters. Okay, in meters. So then periodic time for the excitation function at this situation is equal to 0.22 second. So what is the frequency in radians per second? 25 divided by t. 25 divided by omega is equal t. Then that is equal to 25 divided by 0.22, that is equal to 28.6 radians per second. Okay, 28.6 radians per second. Then let me draw the diagram for this one also. What is the frequency? F cos 28.6 into t. At this position, it produces the maximum amplitude. In this position, this m mass produces the maximum amplitude of vibration. Maximum amplitude of vibration, that maximum value is equal to 1.3 meters per millimeters. Okay, 1.3 millimeters. Okay, maximum amplitude in this situation. Okay, k and the theta. Okay, when discussing the theory classes, by derivating this equation, with respect to frequency ratio, we obtain equation which gives the maximum amplitude ratio, maximum n. So in which situation it is maximized? We have a equation. We have in the equation at omega is equal omega n 1 minus 2 theta square. At this frequency, amplitude ratio become maximum. Amplitude ratio become maximum. Okay, at this frequency. At the same time, let me substitute these values. 28.6, that is equal omega n 1 minus 2 theta. Theta is unknown. Theta square root. Okay, let me take this equation as equation 1. Okay, let me take this equation as equation 1. Again, we are having the equation for the amplitude ratio, maximum amplitude ratio. That means m maximum, that means x divided by delta st maximum value is equal to 1 minus 2 theta 1 minus theta square root. That means at this frequency value, it gives this much of a maximum amplitude ratio, that is equal to this equation, that is given by this equation. M maximum is equal this value. M maximum is equal this value. This amplitude ratio is equal to this value. That is occur when omega is equal omega n 1 minus 2 theta square inside the square root. Okay. So then let me substitute the value for this equation also. X, what is x? 1.3 into 10 to the power of minus 3 divided by delta st. What is delta st? F divided by k, no? F divided by k. What is f is given, no? F is given, that is equal to 25, no? 25 divided by k, f divided by, okay, 25 divided by k, that means 25 divided by k, m, the m is equal to 25, m is equal to 25, that is data is given. So then finally we are getting this value for this, what is the k divided by m? For the k divided by m, we can put the omega n square, so then this term, we can, this is 1, so we are remaining 1.3 into 10 to the power of 3 minus 3, that is equal to this value. Then let me take this equation as equation 2. What I am going to do is, I am going to substitute this omega value in here, in this equation. Okay, this omega value I am going to substitute in this equation. Then by making this omega n into subject, 28.6 divided by the inside is square root 1 minus 2 theta square. Okay, 2 theta square. So then we are getting this equation. If we substitute this omega n in here, we are getting this equation. Okay, by taking this square, 1.3 into 10 to the power minus 3, that is equal to this value. So then this equation we can further simplify. Okay, let me take this equation and simplify. So I am going to take this term to one side, the theta term to one side. Then we are getting 28.6 into square into 1.3 into 10 to the power of minus 3 into 2 divided by, all the theta term I am going to take to one side here. This is over. Okay, 1 minus 2 theta into square divided by theta 1 minus theta into square root. Okay, by taking theta into one side. So then we can further simplify this equation. If you are getting for this term, we can simplify. We will take the square of this term. First I am going to take the square of this term. Okay, by simplifying this equation and by taking the square, we are getting this value. 4.5228, that is equal to square 1 minus 2 theta into square in the square. So then by taking the theta square, 1 minus theta into square. So then by simplifying this equation, I am going to take to one side the 4.15 228 theta into square minus theta into 4 is equal to 1 plus 4 theta into 4 minus 4 theta into square. So then by simplifying this equation, finally we are getting this equation 0 is equal theta into 4 minus theta into square plus 0.1173. You can see by taking theta square as the x, we can write this equation x square minus x plus 0.1173. So then for the by solving this quadratic equation, we are getting the theta square values. Theta square, as the theta square we are getting, for theta square we are getting 0.86428 and another value 0.13572. As the theta we are getting by taking the square of this square root of this value 0.9297, this one 0.3684. You can see we are getting the two solution for the theta. Which one we can accept? Okay. When taking the frequency ratio, you can see always this maximum occur in between omega divided by omega n less than 1 situation. Okay, omega divided by omega less than 1 situation, and also that is greater than, sorry, I will write this one. This maximum occur the situation omega divided by omega n is less than 1 and greater than 0 situation. Omega divided by omega n less than 1 and also greater than 0 situation, this maximum occur. Okay, then what is the omega divided by omega n? What is the omega divided by omega n in this equation? Omega divided by omega n, that is equal to 1 minus 2 theta square. That is equal to omega divided by omega n, that is equal to 1 minus 2 theta into square. Okay, I will write that equation. I am going to use that equation to find the correct value for this theta. Okay, in this problem, omega divided by omega n, that is equal to, from the equation 1, we are getting 1 minus 2 theta into square root. This omega divided by omega n, if this is a maximum, it should occurs in between 0 and 1. In between 0 and 1. So omega divided by omega n should be less than 1 and also greater than 0. So this value also 1 minus 2 theta square root also should less than 1 and also greater than 0. So I am going to take the square over the term 1 minus 2 theta square less than 1. So then I am going to minus 1. Yeah, I am going to take the minus 1, then minus 2 theta square less than 0. So then I am going to multiply by the minus 1 entire equation, 2 theta square 0. So then I am going to divide by the 2. So that we are getting square root of 2. That means that theta should be greater than 0. Then one condition we are getting for this situation. Okay, when the maximum transmissibility, the maximum m is occur, in this situation theta should be less than 1 divided by square root of 2. So 1 divided by square root 2, according to this satisfaction of this inequality, answer for this solution, what is the acceptable value is equal to 0.3684. We can't accept this value because it not satisfy this condition. So then the theta value is equal. Answer is equal 0.3684 theta. Okay. Then problem also asking. Okay. Problem also asking the stiffness of the determine the equivalent stiffness and the damping ratio. Damping ratio we already found. The equivalent stiffness we are going to find. So we are going to use the equation 1. The omega n is equal omega divided by 1 minus 2 theta into square root. This is the equation we are going to use to find that stiffness. Omega n. So what is omega? 28.6 divided by 1 minus 2 into theta square. What is theta square? We already found that theta 0.3684 into square root of total. Then the omega n by simplifying this equation we are getting the omega n. I have already calculated this value. It is equal to 33.5 radians per second. So then omega n, that means the k divided by m square root is equal to 33.5 radians per second. So then we can calculate the k, that is equal to 25 into 33.5 into square. The k I have already calculated this value. It is equal to 2.8 into 10 to the power of 4 Newton per meter.